Hey guys, so I just want to do a quick run through of how you would be able to use JASP instead of SPSS for basically all of the things that we've done so far. So this shouldn't take too long. I'll try to write in the description on YouTube where you can find each test that I'm going to talk about. So I'm using this ANOVA practice data set, but just try to ignore the fact that it's specifically made for ANOVA. We can also use it for t-test or regression or things like that. So in this data set, we have a condition where participants either were given no caffeine or 50 milligrams of caffeine or 100 milligrams of caffeine. And then we have their score on a test and then student type, so whether they're a graduate student or an undergraduate student, and the school type, so whether they go to a private or a public school. So to start out, pretty simple. If you want to get descriptive statistics for this test score, whatever it is that they got, you would add score to the variables right here, and then let's say that you would want to see whether the scores were different by student type. You would add student type right here, and so it would tell you the number of undergraduates that you have and the number of grad students that you have, how many data points are missing, which in this case none, mean, standard deviation, minimum, and maximum. If you want to get more than just these statistics, you can go and check off median, mode, and sum, or if you wanted the mean absolute deviation, you could ask for this. Or if you wanted to see quartiles, so 25th, 50th, and 70th percentile. So you have a lot of options actually. And notice that one good thing about this is that you don't need to have a separate output window like you do in SPSS. This actually just shows up here, and it updates everything with everything that you check. So let's say, for the sake of this, that you would want to get a box plot as well. So let's see. Yep, so if you just check this right here, it's just going to create a box plot for undergraduates and a graduate student. If you change this and use school type instead of student type, it should give you the same. And finally, if you want to see frequencies, and remember, this is like way back when we did things like cumulative probabilities, where you would use the frequency table. Again, you just check this off and you should see a frequency table, I think. All right, so for some reason this isn't showing up. It should show up for score, which is actually it should show up for all of the variables, but for some reason it's not. All right, so we'll have to figure that out, but that's it for the descriptive statistics for now. And then if you remember, reliability analysis is the other thing that you can do in here. This is what we use when we wanted to look at Cronbach's alpha. So let's say that you wanted to get the Cronbach's alpha for a certain like pair of variables, or more than a pair. Unfortunately, in this example, I have 3 nominal variables and only one that is an actual interval scale. So normally you would have 2 of these right here, and notice how this is not really that's giving you a Cronbach's alpha that's very, very tiny. One of the reasons is because this student type variable is binary, so it's not the best measure. But this is how you would, if you wanted to calculate the Cronbach's alpha, that's how you would do it. And another advantage is too, like this, which I don't know that SPSS has, is if you have reverse scaled items, you can just tell JASP and it's just going to do it for you. It's going to reverse the scores. So I think that's an interesting addition. But either way, these are the things that you can find under descriptives. Moving on, if you wanted to do a t-test, this is quite simply, it has the three options: independent samples, paired samples, and then one sample t-test. And one sample t-test, I don't know if we talked about this, but it's basically comparing if your sample mean is different from a certain value. Like usually it would be 0, but so the two that you're most interested in are the independent samples t-test and the paired samples t-test. So let's say, for the sake of this, that we would want to see whether scores were different by condition. So what, like, depending on, well, actually, never mind. Condition has 3 levels, so you can't do a t-test. You need to use one of the variables that has 2 levels. So let's use student type again. And so we want to see if there's a difference between undergraduates and grad students in terms of the scores that they got. And so you can choose which test you want to do from here. This is the student's t-test right here. And so the alternative hypothesis is just that group 1 is different from group 2. This is basically what tells the test that this is going to be a two-tailed test. If you were choosing one of these two, that would be a one-tailed test. Okay, so right here you can see the result of your independent samples t-test. The empirical t-value is minus 2.26. You have 148 degrees of freedom because your sample has 150 participants, and you can figure that out if you go here and if you add 80 and 70, that's your total sample size. It's 150. And so the p-value is under 0.05, so there's a significant difference between undergraduates and grad students in terms of the scores that they got on this. Okay, so the data that I have isn't really in a format that allows us to do a paired t-test because I don't have measures for one time point and then measures for another time point. But the way you would do this is, let's assume that you had a variable that was someone's depression score time 1 and then another variable that was someone's depression score time 2. You would simply add those two in here and check off again that you're doing the student t-test, and then the alternative hypothesis usually would leave it like this. And then if you wanted to, you could also get descriptives or descriptive plots. These are all optional things, but as you can see, JASP already has this table prepared for you where it's going to show you the t-value, the degrees of freedom, and the p-value. So if I did have data in that format, I could show you, but I don't. So just let me know if you have any issues with that. All right, so notice that, oh, never mind. So moving on to ANOVA, this is actually what this data set is made for. So if we go here, a one-way ANOVA, again, means that you have one independent variable and you will always have one dependent variable. So you can put score in the dependent variable box right here. And then let's start with just one predictor. Let's say that we're just interested in condition. So remember, condition has 3 levels, so that's why we couldn't do a t-test, because a t-test only works when you have 2 groups. Okay, so right here on the right, it's telling you the sum of squares for condition. So this is the sum of squares between, the degrees of freedom between, and then the mean square between. And then residuals is what we call error, so or within. So this is sum of squares within, mean squares within, and then degrees of freedom within. This is your F value, which SPSS or JASP automatically compare to the table. And this is the p-value, which is above 0.05, so that means that this is not significant. All right, so here again, like you could do post hoc tests, so the condition is not significant here. But assuming that it was, you could do this and then check off whatever post hoc tests you would want to do. So this would be a standard, and then it would be a 2-key correction. So this is essentially comparing which groups would be different from one another, but because this is not significant, then none of these is significant. Again, if you wanted to see descriptive plots, you could add whatever factors you're interested in. In this case, there's only one. So let me actually move this. Okay. All right, so one thing about JASP is apparently you can just drag this figure and it's going to become larger. So here it just plotted the average score for each condition. It kind of looks like if you get no caffeine or too much caffeine, or whatever, if you think 100 milligrams is too much, you score lower than people who get 50 milligrams of caffeine. But this is not significant because remember, this p-value is not under 0.05, but this is kind of what it looks like from the graph. All right, so now let's move on to do an ANOVA where we have more than just one predictor. So again, we'd put score in the dependent variable box, and then we would put condition, student type, and school type. So we just put all of the variables as predictors. And on the right, we get the ANOVA table. Again, it's telling you the sum of squares for each of these, and you can see that now you don't just have the 3 variables, you also have the interactions between them. So condition by student type, condition by school type, and so on, and then finally the 3-way interaction. So, and then this is the residuals or error. So again, condition isn't significant here either, but it looks like student type is significant because it's under 0.05. So what this means is that it makes a difference whether you're an undergraduate or a graduate student. And the rest of these are not significant, but if any of these were, then you would also have an interaction in this problem. All right. And so again, if you wanted to, you could conduct a post hoc test if you wanted to find out the difference between specific groups, but there's no interaction in here. So, not that there's no interaction, but if condition were significant, then you would have a reason to do a post hoc test, because an ANOVA just tells you that there's a difference between conditions, not which conditions. But in student types and school type, there are just 2 levels, so you don't need to do a post hoc test. All right, so again, now let's say that you're interested in seeing student type as a plot and see which one of these 2 categories scored higher. And so if you look at this, it's pretty obvious that undergrad students scored lower than graduate students. And this time, this is significant because we have the p-value right here. All right, so that's, I think, pretty much all you need to know about the basic test. You could also do a regression. Unfortunately, I don't have data that is suitable for doing a regression. I have data that's suitable for logistic regression, but it's all pretty straightforward. If you just go to the drop down here, let's say that you wanted to correlate something, this is not going to work out nicely because I don't have the continuous data for all of these. But so yeah, it's already not wanting to do this. But all you have to do is put the variables in here. The correlation is just going to automatically appear here. And if you wanted to see Spearman, you could also just check Spearman right here. All right, and then if you wanted to do linear regression, again, you would just put your dependent variable here, and then whatever predictor variable you would want right there.